in terms of history of structure of atom, we discussed the discovery of electrons, protons, and neutrons. Then we discussed a few models, and the two models that we have discussed till now is first of all the Thomson model that suggested the complete electron is of positive charge, in which negatively charged particles are embedded. That means it is just like watermelon. So the complete watermelon is of red color. So that red color represents the positive charge, and the negatively charged are those seeds, small seeds, which can be picked up. Then we went to Rutherford's model. Rutherford model, it told us about the position of the nucleus, and it informed us that the atom, it has a very small nucleus, and the nucleus is only positively charged. Most of the atom, it is completely vacant space. Only the nucleus, which is positively charged, it is very heavy also. So we came to know of protons and neutrons right now. Where they are located, they are inside the nucleus at the center of an atom. But we don't know right now what is the position of electron on the particular atom. We don't know that. That is why we have to understand the behavior of electron. And we saw electron in cathode ray experiment, and electron behaves as light that we can see as a glow. And in order to understand something which looks like light, we have to first of all understand light very deeply. And that is why we are learning about electromagnetic waves. Okay. I hope the sequence is very clear why we are learning about electromagnetic waves. We are learning about electromagnetic waves in order to understand the experiments that was done to find the position of electron in the atom. Okay. Now, regarding electromagnetic waves, firstly, waves, because you have not done waves in your lower standards, I guess. Waves was removed from the syllabus. That is why, first of all, let us understand the wave. So what is a wave? Wave is nothing. You must have seen the wave, but not studied it. Right? This is a wave. Let me draw one more part like this. Okay. Now, the topmost part is known as the crest, and this part is known as trough. Maybe you guys know this part, TROUGH, trough. And the two adjacent crest is known as the lambda. Okay. Now, frequency is something that you must have heard previously also. Frequency is the number of times, the number of waves that pass through a point in a second. So frequency has a unit per second, and hertz. You have seen this hertz. Please tell me. Zoha and Ilham, this is especially Zoha and Ilham. You have seen hertz, right, before?
Yes, sir.
Not in 11th standard. Yes, I mean, before 11th standard, right? Frequency. So this is frequency, and then we have the lambda, and then C is the speed of light. C is the speed of light. All of these terms are related in this manner. Lambda times frequency is given by nu. This looks like V, what we call it nu. This is equal to the speed. So what we can write? We can write nu is equal to C by lambda. Now, this is one of the formulas that we are going to use today also. Nu is equal to C by lambda. Another is the relationship between frequency and energy. Planck's theory we studied, and in that we saw that energy is directly proportional to the frequency of light, and for that we put up a proportionality constant h, which is known as Planck's constant, h nu. The value of h, it is a constant which is equal to 6.626 into 10 to the power minus 34 joule seconds. This is the energy of one photon. Okay. If we have n number of photons, then it becomes E is equal to N into H into nu. Is this clear till here? Yes or no? Please tell me. Ilham and
Yes, sir.
Zuha.
Yes, sir.
Okay. So please note down this formula. Note down this formula is equal to NH nu. And for that, you can also write E is equal to NH C upon lambda. Both of you wrote this formula, yes or no? Nu is equal to C upon lambda. E is equal to NH nu. And also the
Yes.
value of H. Also the value of H. Done with this, yes or no? Please tell me.
Yes, sir. Done.
Okay, fine. Now, also write one more formula. If energy is in, this is for Zoha and Elham only, electron volts. If energy is in electron volts and lambda is in nanometers. You know the value of nano, Ilham and Zoha. Both of you know the value of nano. Nano means 10 to the power. That means 10 to the power minus 9 meters. Okay. So if E is in electron volts, I will tell you what is electron volts, and lambda is given in nanometer. Then the formula becomes E is equal to 1240 divided by lambda. 1240 divided by lambda. And just remember, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. Okay, so this value is the same value as that of the charge of electron. Okay, electron volt. So the charge of 1 electron and the energy that is with 1 electron. Okay, if I put this in a potential, that is equal to 1 potential. Okay, 1 volt potential. Okay, so this is 1.6 into 10 minus 19 joule. For example, let us suppose you have a question, calculate the energy of light with frequency. Let us suppose 62 nanometers with frequency 62 nanometers. Okay, so since this is a nanometer, I can calculate, I can use this formula, calculate the energy in electron volts, then I can convert it to joules. Please see what we are going to do. E is equal to this will be in electron volts. Okay, 1240, whatever value you get, that will be in electron volts. 1240 divided by what is the value of lambda? 62 only. So just write 62. And whatever value you get, you are going to get it as electron volts. Now, what I can write, this is just the half of 124. So 62, 20s are, right? You will get 20 electron volt. In order to convert it to joules, I'm going to do 20 into 1.6 into 10 to the power minus 19. Now you're going to say, okay, sir, 1.6 तो बहुत difficult हो जाएगा multiply करना. No, it is not difficult. You're going to write this in decimal points. Sorry, not in decimals, fraction. 16 by 10. Now, what is 16 by 10? You can just cancel this and this too. This will become what? This will become 32 into 10 to the power minus 90, which will be equal to how much? Which will be equal to 3.2 joules. Joules 3.2 into 10 minus 18 joules. Zuha and Ilham, is this okay with you guys? Yes or no? Please tell me. This calculations and
Yes,
everything.
Yes, sir.
Say it. Okay. If anyone is having any doubt here, till here, please let me know. If you want me to explain anything once again, please let me know. Okay, no problem. Let us move on and write a question. Let me see. I don't know whether this question was there in the. I don't think so. I don't know whether I gave this in the homework or not. Let me just see that. 500. No, I don't think so. We have not given that. No. You see here. Write the question. 150 watt. 150 watt bulb emits radiation. Emits radiation. Having wavelength. Having wavelength 4,500 angstrom. 4,500 angstrom. 8%. This is percentage, okay? 8% of this energy is emitted by the bulb. 8% of this energy is emitted by the bulb. Calculate the number of quanta. Emitted by the bulb in 1 second. Please write the question. In 10th standard, you had current, electricity, and all of these things, right?
Yes, sir.
Yes, sir. Right, everyone? Okay.
Yes, sir.
All of you wrote the question, yes or no? Please tell me.
No, sir, just a minute.
Okay, fine. Done, Ilham?
Yes, sir.
Okay, fine. Fine. Since you guys are done, I will just decrease the size of this question so that I have space for my. Yep, I think that much is fine. See you guys. Okay. So who is going to tell me what is the WATT? It is the unit of which particular measurement? Tell me. What property? What is the unit of? For example, current, electricity में पढ़ा होगा आप लोगों ने, right? Volt is the unit for potential difference. Ampere is the unit for current. Watt is the unit for? What is the unit for? Yes, Ilham? Sorry, loudly, please.
So electric power.
Power. Very good. Yes, correct. It is power. So they have given us power is equal to 150 watt. And what is 1 watt? That is energy that is given per second, right? Energy in terms of joules per second. All of you remember this? Yes or no? Please tell me.
Yes, sir.
Right? Joule per second. Fine. So what is the power of the bulb? What is the power of the bulb? Tell me, guys. What is the power of the bulb? 150 joules per second. So per second it is emitting how much energy? It is emitting how much energy? 150 joules. But they have told us 8% of this energy gets emitted. Can you see that? 8% of this energy is emitted by the bulb. Even though the power of the bulb is 150 joules, that is 150 watt, but it emits how much? Only 8%. So I can write in 1 second. All of you understood the second line? Yes or no? Please tell me 8% of this energy is emitted by the bulb, right?
Yes, sir.
So now you have to calculate the 8% of 150. 8% of 150. So I can say that in 1 second, energy that is actual energy that is emitted will be equal to 150 multiplied by 8% means 8 upon 100.
Yes.
I can cancel both of these terms, and then I can cancel this by 2, this by 3, and this by 4. I hope all of you guys saw this.
Yes, sir.
No, then please see once again my cancellations. So first of all, 0 and 0 cancelled. Then I cancelled the 10, both of 10 and 50, 10 by 5, so I got 2, 15 by 5, so I got 3. Then I cancelled 2, 4s are 8. Now my answer was equal to 4 3s are 12 joule. Even though the power of the bulb is 150 joules, but it is emitting how much energy per second? 12 joule per second. Is this clear? Yes or no? Please tell me.
Yes, sir.
Now, once you know the energy, we can easily calculate the. Now, obviously, that bulb will be not emitting only one photon, it will be emitting multiple photons. So we are going to use which formula? We are going to use E is equal to NHC upon lambda. We are using lambda because we have been given wavelength that is 4500 angstrom. 4500 angstrom. Okay. Now we are going to just plug in the values here. We need to calculate the N. So I'm going to keep the N on one side, and I will get E into lambda divided by H into C. So the energy that we have is 12 joules. We will write all the units multiplied by wavelength is 4500 angstrom. That means 10 to the power minus 10 meters. Divided by H, which is equal to 6.626 into 10 to the power minus 34 joules second, into second, not per second, it is into second, multiplied by C, which is equal to 3 into 10 to the power 8 meter per second. Is this clear? Yes or no? Please tell me. Everything till here is clear?
Yes, sir.
What about others? Ilham, Zoha, Afaf, Rishita, आप लोग बताएं.
Yes, sir. Yes, sir. Clear.
Zoha, what about you?
Yes, sir.
Zoha, आप ध्यान से पढ़ेंगे है ना? You have difficulty in this portion only, right? In atomic structure.
No, sir.
Zoha, no, आपको इसमें problem नहीं है?
No, sir.
अच्छा, okay, fine. I thought you had problem in this part only. Okay. So now, before solving anything, first of all, we are going to solve the units. So let's solve the units. Joules will get cancelled by joules. Meter will get cancelled by meter. Here we have second, here we have second inverse. So both of these will also get cancelled. And obviously, since we are finding number of photons, so number will not have any units, right? Now we will arrange this in a manner such that we have powers of 10 properly. So we'll have 12 into 45 into 10 to the power 2, right? 10 to the power 2, because here we have 100, minus 10. because 10 to the power minus 10 divided by 6.626 into 10 to the power minus 34, it will go above, it will become plus 34, right? Then we have into 3. Here we have 10 to the power 8, it will go above and it will become 10 to the power minus 8. So here minus 8. Now we can do calculation sum here. So 12 into 45 divided by 6.626 into 3 multiplied by 10 to the power. 2 minus 10 is minus 8. Minus 8 and minus 8 is minus 16. Will at last get 34 minus 16, which will be equal to how much? Tell me, guys. 34 minus 16. 34 minus 16 will be equal to how much? 32.
No, sir. No, sir.
34 minus 16.
18.
Or 18.
18. Yes, correct. Right. So we are going to get here 18. 10 to the power 18. Okay. Now we can solve this also. 4s are. We are going to get 45 into 4. 45 into 2 is 90 and 90 into 2 is equal to how much? 180. So 180 divided by 6.626 into 10 to the power 18. Now 6.626, if you can divide by 180, you can divide 6.6 or divide करके देखिए. Maybe divide this value. 6.6. 180 divided by 6.6. देखिए इसका आंसर लिख सकते हैं 180 divided by 6.6. Okay. Into 10 to the power 18. We can further write this as how much? 180 divided by 66 into 10 to the power minus 1 into 10 to the power into 10 to the power
18.
how much? 18, right? Now 16 can be divided in such a way. 16, 6. 6 that will be 11 and this will be 30. Correct? I'm dividing both these numbers by 6. So 6 ones are 6 and 6 ones are 6. Right? So 66 is 11 and 6 3s are 18 and 1 0. Now you have got 30 divided by 11 into 10 to the power minus 1. So it will become plus 1, which is 10 to the power 19. Now this will be equal to how much? 2s are right. 11 2s are 22. Remaining is 8. So 0.7. So 0.7, then it will be again 27, 27, 27, 27, 2 like this. So 2.72 into 10 to the power 19 quanta. This many quanta will be there. Okay, so please write this down. Let me know once you're done. If you understood this, yes or no, please tell me.
Yes, sir.
Yes. Yes, sir.
Please write this down. Let me know once you're done.
Done, sir.
Done. Okay. Now let us see. Let us use the same values, but we are going to do this with the formula 121240 divided by lambda in nanometers. Okay. So energy we have got as 12 joules. We want to we have to convert first of all this into electron volts. So what is the relationship? 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So if I put this below, joules will become equal to 1 divided by 1.6 into 10 to the power minus 19 electron volts. Correct? Yes or no? Please tell me.
Yes, sir.
Okay. Now, if I have lambda is equal to 4500 angstrom, which is equal to 4500 into 10 to the power minus 10 meters, and I want to convert this into 10 to the power minus 9. So what will be the value? 4450 into 10 to the power minus 9 meters, which will be equal to 450 nanometer. Correct, guys? Please tell me.
Yes, sir.
Now, these calculations should be in your head itself. Now, the equation will become what? E is equal to n into 1240 divided by lambda. E in electron volts, I will write 12. And instead of joules, I will write 1 upon 1.6 into 10 to the power minus 19. Right? This will be equal to n 1240 divided by lambda. Lambda is 450. Okay, now you can shift these values there. N will be equal to 12 into 450 into 10 to the power 19, because minus 19 will go above, it will become plus 19, divided by 1.6 into 1240. Okay, so let us see which calculation was more easy. So this is going to be 0 and 0 will get cancelled. And I think 12 and 124 will also get cancelled, right? No, it won't. No, 12 tens I is that much. Fine. So it won't be getting cancelled. Which calculation was easy? 12 into 45 into 10 to the power 19. And I can write this 16 divided by 10. Divided by 10 will go above, it will become 10 to the power 20. 10 to the power 20. This is nothing, this is 16 into 124. So 16 and 45 and 124 are here. Can we do any quick maths here? Is it possible? 45 into 2 is 90 into 6. So this will be 90 into 6 divided by 124 into 16. 124 into 16. 16. I can 4 4s are 16 and 8 2s are 16, right? I can do it 8 into 2 into 124, 10 to the power 20. I think it will be a bit easier. So 2 and 3s are, right? And then what we can cancel even more now. 124 into 8. I think these things can be cancelled easily. It will not take much time. Let's do it now. So 90 divided by 8. So it will be 4 and it will be 45. So we have 45 into 3 divided by 4 into 124. Okay, into 10 to the power 20, which will be equal to how much? 45 3s will be equal to 90. 90 and 45 is 135. What was our previous answer? 2.72, no? It will be approximately there only, 10 to the power 19. No, 3 124 will also not get divided, right? So even though with approximation we got this value, but I think this calculation was easier. Okay, so I was just checking here right now that what calculations are better. So sometimes this calculation will be better, and sometimes this 1240 calculation will be better. Okay, so you can solve this furthermore. If you like odd and even numbers, then you can get the values. Similar value we are going to get 2.7 into 10 to the power 19. You are going to get. I just did it in my calculator right now. 5 into 3 divided by 4 into 124. You will get this value as 27. 2.7 into 10 to the power 90. The same value you are going to get. Okay, but again, this was a bit easier once we approximated this as 6.6. Now moving on to the next topic, that is photoelectric effect. Okay, please write this topic, photoelectric effect. Then we will explain why we are learning about photoelectric effect. Please write the ejection of electron from metal surface. The ejection of electron from metal surface when light of suitable frequency, when light of suitable frequency strikes the surface of metal is called photoelectric effect. Okay, it's called photoelectric effect. Please write this down. I hope you have written these points. Now please see what actually happens. Now first of the first picture here, it shows you what happens actually, that when a particular light, electromagnetic wave of suitable frequency hits metal surface, then the negatively it gets ejected. This is what is happening. That is photoelectric effect, and how it was done, which is shown in this next figure. So what Einstein was the one who experimented on photoelectric effect. What he did was, he was not giving any battery source right now. He was not giving any battery source. That is why this ampere, it should not show any voltage also, right? This conductometer should not show any conductance here. So, but what happened when he struck light on this metal surface, there was some measurements in this conductometer. That means obviously electrons were flowing here. How can electrons flow without any battery? So he theorized that, okay, because we are striking this metal surface with a particular frequency of light, electrons are getting ejected, and these electrons are reaching this another electrode, and then the electricity, and then the electron moves, showing some measurement in the conductometer. So this is how it was experimented. But conclusion, what happened? Conclusion is that when we strike electromagnetic radiation on metal surface, then electrons get ejected. Then what happens? Electrons get ejected. Now please write next. All of you understood what photoelectric effect? Yes or no? Please tell me. I hope that is simple, right?
Yes, yes.
If you strike
Yes.
the metal surface, yes, Anna. If you strike the metal surface with a particular frequency of light, electrons get ejected. That was seen. What was seen? Please write. Certain frequencies of light were able to eject electron from metal surface. Eject electron from metal surface. Right, next point. Now, each and every frequency will have certain energy. Yes or no, please tell me. Right. Each and every frequency of light will have certain energy by the formula E is equal to H nu. Nu is frequency. So each and every frequency will have some energy. Correct, hey guys? Hi, Anna, Abdul Hamid, Amna, Ilham.
Yes, sir. Yes.
Yeah. Okay. That means there will be some minimum energy which is required in order to eject the electron. That minimum energy was known as threshold energy or work function. Please write the minimum amount of energy required by electron to cause photoelectric effect. To cause photoelectric effect is called threshold energy or work function. Threshold energy, it is denoted by W, which will be equal to E naught. What is E naught? Threshold energy. What is W? Same thing. Threshold energy, work function. All of these are same thing. There's no difference. E naught ho jaye, W ho jaye, work function ho jaye, threshold energy. All of these are same. And will be equal to H, that is Planck's constant, multiplied by a particular frequency that will be known as now threshold frequency. Next is, if I want to convert this to lambda, then I can write E naught is equal to H C upon lambda naught, because Planck's constant H is also constant. Speed of light is also constant, right? That means this lambda naught will be now this is not here. This is threshold wavelength. All of you wrote this down? Yes or no? Please tell me.
Yes, sir. Yes, sir.
All of you wrote this down? Now,
Yes, sir.
Now what you need to do is, thoda sa bas aur sun lijiye aap. Then I will explain actually what is the consequence of this in terms of the atomic structure. है ना? Atomic structure से कैसे लेना देना है उसको हम लोग थोड़ा सा पढ़ेंगे. But write a few more points. Can I say that if I have lower work function, if my threshold energy is lower, that means it is easier to eject electrons? Correct, hai guys? Hi, Anna.
Yes, sir.
So write next point. Lower the work function, easier is ejection of electron. Easier is ejection of electron. Now, next thing is that if I give energy more than required, how much energy are we giving? Please tell me, guys. Threshold energy is the required energy to eject electron from the metal surface, right? But we are giving more than required. How much we are giving? Abdul Hamid, Afaf, Amna, Akib,
More than
Ilham.
required.
More than required.
More
Rishita,
than
are you not in
required.
class? Yes. Rishita, are you there in class?
Yes, sir.
Okay, fine, very good. Now, if you are giving more than required, then that energy will be converted to kinetic energy. So, if the electron is being ejected only, so it will sit on the metal surface, above the metal surface. But if you are giving more energy, that means you are kicking it very hard. So it will be ejected with some kinetic energy, with some motion, with some speed, with some velocity. सही है guys, हाँ या ना?
Yes,
Correct
sir.
है?
Yes.
So we are going to write one more point. If energy of light is greater than, if energy of light is greater than the E naught. E naught is threshold energy, right? Is greater than threshold energy. Then the extra energy will be converted to kinetic energy of electron. Will be converted to kinetic energy of electron. Okay. So let us suppose that E is the energy that we are giving. So any energy, some of it will be used as work function, threshold energy, everything is same. I hope I said that. Plus the rest of the energy will be used as kinetic energy. Correct, guys? Yes or no, please tell me.
Yes, sir. Yes, sir.
In order to calculate the kinetic energy of the electron that has been ejected, what we can write, kinetic energy will be equal to the energy that has been given minus the work function, right? E is the energy given, the
Yes, sir.
light that we are striking on the metal surface, whatever frequency light. Now kinetic energy, we can further write it as E will be H into frequency of light that we are striking the surface with minus H into mu naught. Mu naught is the frequency that is required. We can take the H common and we will get a formula mu minus mu naught. Kinetic energy of the electron that is being ejected after photoelectric effect is equal to H multiplied by mu minus mu. Done everyone? Yes or no, please tell me.
Done, sir.
Okay.
Done, sir.
Now write a question. A light bulb having wavelength, light bulb having wavelength 62 nanometer, strikes metal surface. The work function of metal surface is 13 electron volt. Calculate the kinetic energy of electron ejected. Okay, so energy is equal to the work function plus kinetic energy. So they have given us directly the work function, है ना? तो हम लोग सीधा उसी को यूज कर लेंगे, ठीक है? So kinetic energy will be equal to E minus the
E
work
minus
function.
work function.
Yeah, so E will be equal to what? E will be, since it is given in nanometers and the energy we want in electron volts, so I can write 1240 divided by 62. This will give me the energy in electron volts minus the work
Yes.
function is 13. Right? Now, whatever answer we are going to get, we are going to get in terms of electron volts only, because this is also electron volts, this is also electron volts. 621240 will be equal to 20 minus 13 electron volts. This will be equal to how much? 7 electron volts, right? Correct, guys? Please tell me. Now, from this, you can easily convert to joules. 7 into 1.6 into 10 to the power minus how much? 19 joules. This will be 7 into 16 into 10 to the power minus 20 joules. 16 sevens are how much? Tell me, guys. 16 sevens are 16 sevens are, oh my god, no one.
One, one, two.
Very good. In scientific notation, it will be equal to 1.12 into 10 to the power minus 18 joules. Yes, Afaf, you are saying something?
No, sir.
All of you understood this? Yes or no, please tell me. Akib, Amna,
Yes, sir.
Ilham, Joel, Rishita.
Yes, sir. Yes, sir.
Very good. Okay. Done, everyone? All of you wrote this down?
Yes, sir. Done.
Yes, sir.
Done? Okay. Fine. That means we can write a conclusion also from here. From photoelectric effect, we can write a conclusion. Please write. When light strikes metal, then one of three things can happen. One of three things can happen. What are the three things which can happen? If the given energy, it is less than work function, then nothing happens. है ना? जो required energy उसे अगर हमने कम डाल दिया, then nothing is happening. No photoelectric effect. Another case is when the given energy is completely equal to the required energy, then electron is ejected. पर क्या इसके पास kinetic energy होगी? Will it have any kinetic energy?
No,
or
sir.
all, है ना? So with zero kinetic energy. With zero kinetic energy, because all the energy will be used for ejecting the electron. Last is when the given energy is greater than the work function, then electron is ejected with kinetic energy. All of you wrote this down, yes or no, please tell me.
Yes, sir. Written.
Yes, sir.
Now let us understand what is the significance of photoelectric effect. What is the significance of photoelectric effect in the structure of atom, and also especially the position of the electron, है ना, उसके बारे में. So please see. Right now we have a model of atom in which nucleus is in the center. Right now, the scientists knew that the atom is present and the atom has a nucleus, and the nucleus is in the center of the atom. Nucleus is in the center of the atom. And they also knew that nucleus is positively charged. And they also knew that there are electrons inside the atom. So what are the information? In first information is nucleus is in the center and nucleus is positively charged, and electron is present in the atom. Where it is present, position is not known. Position is not. Now, wherever the electron may be, okay, wherever the electron is, I don't know wherever the electron is, but if I have more than one number of electrons, for example, if I take metal such as, what metal can I take? I can take metal such as aluminium, beryllium, okay, cesium, copper. All of these will have more than one electron inside them. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Right, more than one electron. Now the electron that is getting ejected here, the electron which will be getting ejected, it will be the most loosely bound electron. The electron which is not having a good attraction with the nucleus. Correct, guys? Yes or no? Please tell me.
Yes, sir.
What about others? What is happening here? We are in the atomic level. What we saw was we were striking a metal surface, right? What we saw that we are striking a metal surface. We have not seen it, atoms and all, right? But we know that metal surface has atoms. Inside the atoms only there are electrons. So what actually is happening is we are striking light inside the atom, and that too of a particular frequency of light. Not 1 nanometer less, not 1 nanometer more. Particular frequency of light is ejecting electron. Now I will show you a few things. Okay, I will show you a few things. Tell me which electron will require greater energy. Which electron will require greater energy? The white one as we have shown here, or the green one?
Green
to get
one.
ejected.
Green one.
Green one, because it is nearer to the nucleus.
Near
Because
to
it
the
is nearer
Yes,
to
nucleus.
the nucleus.
It has more attraction to the nucleus.
Correct. It will be experiencing more attraction towards the nucleus. Okay. Now I will show you some work function. That means some threshold energy values. उससे एक चीज जो बोर ने पता किया था उसी चीज को वैसे ही हम लोग देखेंगे, है ना. Photoelectric effect, it was done by whom? By Einstein, है ना. But उसके observation से किसने पता किया? Observations was taken by Niels Bohr, and Bohr gave the Bohr model. So you have here the element and their work function in electron volts. Okay, I'm hiding this atom because we don't need it right now. And I will take a few elements from here, and few elements are beryllium, and I will take calcium, I will take magnesium, and that's it. I mean, that's fine. Now, can I arrange it in order of like which is requiring the most amount of energy than the least? Tell me which is requiring the most amount of energy: beryllium, calcium, and magnesium.
Beryllium.
Beryllium is requiring the most. And after that,
Magnesium, then calcium.
Then calcium.
magnesium and then calcium, right? Magnesium and then calcium. Correct. Now, can I say that whatever the electron present in beryllium, it is nearer to nucleus? Can I say that?
Yes, sir.
Yes, sir.
Magnesium one is a bit away,
Yes.
and calcium is quite away, quite far away. Correct, guys? Please tell me.
Yes, sir.
Yes, sir.
Right? And if you see the sequence, this is the same sequence in our modern periodic table also. right? In our modern periodic table, we have the same sequence here. Beryllium is having it is having small size, and the outermost electron is nearer. And so Bohr said, okay, fine. If each and every electron it is requiring a particular energy to get ejected, that means for beryllium this electron will be here. For magnesium the electron will be here. For calcium the electron will be here, a bit far away. And whatever be the beryllium source, no matter where you are taking the beryllium from, it is having the same work function. That means in each and every beryllium atom, the electron is in a particular distance away from the nucleus. Because agar electron apna distance nucleus se change kar raha hota, if it was changing the distance from the nucleus, then we would be getting different work function for different beryllium, correct? Sometimes we will be getting 5, sometimes we will be, let us suppose it is changing position. For example, I'm saying, because we don't know right now, what is the position of electron. Now, since it is giving me the same work function, that means the distance of electron from the nucleus is constant. Correct, guys?
Yes, sir.
Yes.
And that is the reason, and this is the initial phase of Bohr's model. So Bohr said, okay, fine. That means electron are away from nucleus at a particular distance, and that distance is going to be distinct for each and every element. The outermost electron of beryllium atom will be different than the outermost electron of the calcium atom, and the distance of nucleus and the outermost electron of magnesium atom will also be different. So this work function gave an idea about many things. It gave us the idea that electron is revolving around the nucleus. It is revolving around the nucleus at a particular distance, and that distance is unique for a particular atom. Right? So here we came to know about the sizes of atom also. So from the work function, we can predict that beryllium atom is small. From work function, we can predict calcium atom is small. From the same way, we can predict, calcium atom is a bit larger, and magnesium atom is a bit larger, and calcium is the biggest amount, beryllium, calcium, and magnesium. So there are many things which we know, and one of the things that Bohr pointed out was the orbiting of electron, and in a particular orbit with certain energy and certain distance from the nucleus. Is this understood? Yes or no? Please tell me how work function helped Bohr.
Yes, sir.
Yes.
Now, once you understood that, we can write about the Bohr model now. Right? Bohr's model of atom. Please write. And I hope आपको ये भी समझ में आ गया कि work function समझ में नहीं आता अगर हमें wave नहीं पता होता. If we did not know about the frequency, if we did not know about the relationship between energy and the frequency of light, we would not have understood the work function. Right? That is why electromagnetic waves is there in your atomic structure chapter. Otherwise, there is no use of electromagnetic waves in the atomic structure chapter. It is just to understand the photoelectric effect, and because photoelectric effect is the one which is giving suggestions about the Bohr's model. Okay? So understand the sequence in which the NCERT have given everything. Fine. Bohr model, please write number 1 point. Electron is revolving in circular path around the nucleus called orbit or shell or energy level. अच्छा, energy level क्यों कहा उसने? He said it is an energy level because each and every element has a particular work function. Work function is nothing but the energy required to remove electron. So that electron will be having certain energy. That is why it is requiring energy to get removed. So that is also called as energy level or shell or orbit. And the second point. If the electron is present in a particular orbit then it can neither radiate energy, that means lose energy, nor absorb energy. That means gain energy. And please remember, when I say when electron is present in a particular orbit, that means if it while circling, you may feel that in circling there is some kinetic energy used. So that kinetic energy, some of the energy is used as kinetic energy, so energy will be lost for the electron. That does not happen. In a very small level, that does not happen. Okay. So when the electron is orbiting, it is not losing energy, neither it is gaining energy. Okay. So energy of each orbit is fixed. Therefore, we can write energy of each orbit is fixed. Right, next. Energy of electron is associated, or rather you write like energy of electron changes with change in its orbit. Fourth point, the transition of electron from one orbit to another is accompanied with change in energy Okay. Now, Bohr did not stop with the theories. He also gave some mathematical analysis of the atom. And we study this in mathematical analysis of the Bohr's model. He talked about radius of an orbit, energy of an orbit, and many things. So we are going to look at those parts now.
Sir,
Yes, tell me.
can you explain the third and fourth point once again?
Yeah, sure. Fine. Just a second. Mathematical analysis of Bohr's model. I mean, it is saying almost the same thing, that energy of electron changes with change in its orbit. Okay. So for example, let us suppose, let me make it here only, otherwise it will disfigure the PDF if I want some way. Here we have nucleus, here we have the first orbit, right? So if an electron is present in the first orbit, it is near to the nucleus, right? So it will have a certain energy. Okay. But if the same electron, it is present in the second orbit, right? So it is also going to have a particular energy. Now, please understand that. What is the first point saying? The energy of electron change in its orbit. How can the energy of electron change? It can change only by two ways, by either radiating energy or absorbing energy. So for example, if I have electron in the first orbit, right?
Yes, sir.
More energy, I strike it with a particular frequency of light, and that frequency is equal to the difference between the first orbit and second orbit. Then the electron will jump and it will go to the second orbit. Okay. One thing is to be very clear. I mean, these are not actually, जैसे आपको लग रहा है ना कि these are circular path. Okay. So these are not actually like circular path. ऐसा नहीं कि जैसे solar system में we have sun in the middle, then we have the different planets moving. The energy of electron is the shell. समझ में आ रही है आपको? I mean, the position of electron does not change, only the energy changes.
Yes, sir.
Okay. Okay. So these are not actually speaking shells, but we say that it jumps from 1 to 2 so that you understand it a bit well. It changes, it goes from first shell to second shell, and it is accompanied with change in energy. So this
Yes,
is the
sir.
change in energy. Okay. Now let us see at the mathematical analysis of Bohr's model. Number one, he gave the radius of atom, or rather the radius of an orbit. Now radius of an orbit, आप घबराइएगा नहीं. He formulated this as n square h square divided by 4 pi square m e square. 4 pi square m e square. This was given for hydrogen atom. For hydrogen atom. Actually speaking, not in a circular path. Actually speaking, not in a circular path. Okay. Obviously, Bohr's model had also some limitation. Uski energy of electron is correct, but they are not moving in actual circular paths. Actually, वैसा नहीं है. But energy level वाली बात उसकी सही है. That each and every electron has some particular energy that is associated with its orbit. ठीक है, तो समझाने के लिए orbit is good, ना? That is why it was taken. And this model is considered to be very near to the reality, because all the calculation of the radius of an orbit and everything was quite good. Okay, so radius of an orbit is for hydrogen atom is this much, and radius of the orbit for any other atom will be n square h square divided by 4 pi square m e square multiplied by z. Okay, now please listen here, guys. H is also a constant, Planck's constant. 4 is also a constant, pi is also constant. The mass of electron is also constant. Elementary charge is also constant. So all of these things are a constant, and the value came out to be, what you have to remember, is equal to 0.529 multiplied divided by z angstrom, and here you are going to get the radius of the orbit in angstrom. Okay, now this is the formula that you have to remember. Fine. Now what is n here? N is the shell number or the orbit number. What is Z? Z is the atomic number. Is this clear? Yes or no? Please tell me. छोटा फॉर्मूला याद कर लेंगे, हाँ या ना?
Yes, sir.
Okay. Now, see here. Calculate the radius of first orbit of hydrogen atom. क्या हो जाएगा बताइए? Radius of the first orbit will be equal to 0.529 multiplied by number. Oh, tell me. Orbit number is? Oh my God. 1 square divided by, what is the atomic number for a hydrogen atom? Yes, very good. 1. And you will get this value in angstrom. So what is the radius? Radius will be equal to
0.529
angstrom.
Yeah.
So no, please tell me. Okay, that means
Yes.
they can also give you the radius of the first orbit of hydrogen atom, and then they will ask you to calculate. Okay, so write a note here, because ये angstrom की value change हो सकती है ना, angstrom के अलावा they can give anything else also. So please write, if R1 मतलब radius of the first orbit, radius of first orbit of is equal to A. कितना वैल्यू दिया उन्होंने? A दिया. No matter what the unit is, no matter what the unit is, then radius of any other orbit of any other atom will be equal to A times n square divided by Z. See here, guys. I hope you understood this formula. Yes or no? Please tell me. We saw that
Yes,
this
sir.
is the value of radius of any orbit of any atom. And this we saw that this value is nothing but the radius of the first orbit of hydrogen atom. So in general, we can write the formula in terms of the radius of first orbit of hydrogen atom. Is this clear? Yes or no? Please tell me.
Yes, sir.
एक सवाल करिए. If the radius of first orbit of hydrogen atom is x pm, कितना? X picometer, x value, then the value of fourth orbit will be, you have some options. Option A, 4 into x, 4x picometer. If you know the answer, you will give the answer in the Zoom chat. Please don't say it out loud. 10x picometer, 16x picometer, 12x picometer. है ना? फोर्थ ऑर्बिट ऑफ व्हाट? हाइड्रोजन एटम होंगे ना. चलिए इसमें प्लग इन करके आप लोग ऐसे करें. बहुत छोटी छोटी चीजें हैं, लेकिन आप लोग रेडियस ऑर्बिट और ये सब देख के थोड़ा डर जाते हैं. आराम से वैल्यू इसको प्लग इन करेंगे, आराम से आंसर आ जाएगा. नो आंसर. किसी को नहीं आ रहा है? टेल मी गाइस. अब्दुल हमीद, अफाफ, आमना, आकिब, इल्हाम, जोएल, रिशिता एंड जोहा. अच्छा रिशिता, रिशिता
Yes, sir.
टेल मी समथिंग. आपने एक क्लास मिस किया ना, लास्ट क्लास.
हाँ सर.
आपको थोड़ा फर्क नजर आ रहा है कि आज थोड़ा कम समझ में आ रहा है?
Yes, sir.
है ना? थोड़ा सा वो हमको भी दिख रहा है, बिकॉज आपके आंसर्स उतने नहीं आ रहे, आप उतना एक्टिव नहीं है ना? तो ट्राई कीजिएगा, ऑल ऑफ यू गाइस, ओके. ट्राई दैट यू अटेंड ईच एंड एवरी लेक्चर. इफ नॉट, बाय चांस यू कैन नॉट, देन प्लीज वॉच द रिकॉर्डिंग, मेक द नोट्स, बी कंप्लीट. आप प्रिपेयर्ड रहें, ज्यादा प्रिपेयर्ड रहें. ठीक है? ओके, जोहा हैज गिवन द आंसर. इसमें प्लग इन करें ना, क्या हो गया? Plug the values here. What is A? Radius of the first orbit of hydrogen atom. What is the radius of the first orbit of hydrogen atom? देखें. And they're asking for the fourth orbit for hydrogen atom. Fourth orbit n की value plug in करें. Rishita, you have been given the options. Na, Joel correct. Very good, Joel. Rishita, see, you have been given the options. A, B, C, D आप बस बताएं, Rishita.
Yes, sir.
Joel सही है, Zoha सही है. Very good. लिखिए आप लोग, ओके। व्हाट इज द वैल्यू ऑफ n? लिखिए, n है, z है और a है, सबकी वैल्यू लिखिए क्या होगी। व्हाट इज द वैल्यू ऑफ n? टेल मी गाइस, ऑल ऑफ यू गाइस टेल मी फॉर दिस क्वेश्चन, व्हाट इज द वैल्यू ऑफ n?
Sir, 4.
4.
Yeah.
What is the value
4
of
square.
z? What is the value of
Z
z?
is 4.
Z is
4.
z क्या होता है अब्दुल हमीद?
1, sir.
What is the meaning? What is the meaning of z, Abdul Hamid?
Sir, atomic
Amna, what
number.
is the meaning? Atomic number क्या होगा? किसका फाइंड कर रहे हैं हम लोग? हाइड्रोजन एटम ना?
Yes, sir. Yes, sir.
तो कितना हो जाएगा बताइए?
1.
1. And what is the value of A? जो रेडियस ऑफ फर्स्ट ऑर्बिट ऑफ हाइड्रोजन एटम कितना दिया हुआ है? Is how much?
X picometer.
X पिकोमीटर. अब प्लग इन कीजिए ना, इसमें हो गया, आंसर आ जाएगा। क्या डिफिकल्ट था? डिफिकल्ट था, आई अंडरस्टैंड, मतलब बहुत आसान तो नहीं था, थोड़ा सा प्रैक्टिस चाहिए आप लोगों को, तभी आएगा। प्लग इन द वैल्यूज एंड टेल मी व्हाट इज द आंसर। ठीक है, तो खेल एटलीस्ट, है ना, सबका आ गया आंसर, है ना, आसान था, हाँ या ना बताएं,
Yes, sir.
है ना, तो हारना नहीं है, 16x पिकोमीटर होगा, राइट। चलिए, नाउ राइट अ नोट। You saw that for same element, the radius is only proportional to n square. सिर्फ ऑर्बिट पे डिपेंड करेगा, बिकॉज z तो आपका क्या है, सेम रहेगा। फॉर डिफरेंट एलिमेंट the radius will be directly proportional to n square and inversely proportional to z. ठीक है, क्या मतलब है इसका? लेट अस सपोज जो r1 ऑफ हाइड्रोजन है, रेडियस फर्स्ट ऑर्बिट ऑफ रेडियस एटम, इसको दिया हुआ कितना, x पिकोमीटर, है ना, पुराने सवाल की तरह x पिकोमीटर, एंड दे आर सेइंग find radius of, please see here, don't write, find radius of third orbit of lithium atom. ठीक है, in this what you need to do, you tell me, they have given the radius of hydrogen atom and they're asking the radius of lithium atom. So same है element या different element? Element is same or different?
Different.
Different.
है ना, different है. So which one we are going to use? The second one, right? So radius will be directly proportional to n square. So what is the value of n here? We have to find the radius of which orbit?
Third orbit.
Third orbit. So 3. And what is the value of Z? Atomic number of lithium is 3. So we can write
3.
R will be equal to what? R3 of lithium will be equal to what is A? A is x picometer.
X into 3 squared by 3.
Divided by 3. 3 and this is
3x.
will get cancelled and we'll get 3x
3x
picometer.
picometer.
है ना, बाकी तो फिर अब ये x की वैल्यू जो भी हो कैलकुलेशन हो जाएगी, ठीक है ना, कंसेप्चुअली दिस इज गोइंग टू बी द आंसर। ठीक है, सो नंबर्स देख लेंगे,
Yes,
क्या आपको घबराहट नहीं है ना, और सवाल ज्यादातर इसी तरह से रहेंगे, ठीक है, बहुत ज्यादा कैलकुलेशन, अगेन कैलकुलेशंस तो कैलकुलेशंस ही रहेंगी, दे आर नॉट गोइंग टू चेंज, राइट, बट दिस कंसेप्ट आपको याद रखना है, राइट। नेक्स्ट पॉइंट, दैट इज द एनर्जी ऑफ इलेक्ट्रॉन। How are we writing these things down? अच्छा, white से लिख रहा है। Second is energy of electron. Energy of electron. Now, energy of the electron in nth orbit. Okay, energy of electron in nth orbit will be equal to minus 13.6 into z square divided by n square. This will be electron volts per atom. If you want to write this in joules, then En will be equal to minus 1312 this will be the same, z square upon n square kilojoule per mole. Okay, now what is the negative sign telling me about? Negative sign कुछ नहीं बता रहा है, पता नहीं आप लोगों ने अभी नहीं पढ़ा है, but Coulomb's law पढ़ा है आप लोगों ने? Tell me guys, have you heard of Coulomb's law? No, ना?
No, sir.
Gravitation, G m1 m2 upon r square, ये पढ़ा है आप लोगों ने?
Yes.
Yes,
All of
sir.
you हमने पढ़ा है ना? So this gives you the force of attraction between two masses. Similarly, force of attraction between two charges is very similar जो 12th में आप पढ़ने वाले हैं in physics. It is K, a constant, जैसे G constant है, Q1 Q2 upon R square. ठीक है? Now tell me, charges, mass can be only positive, but charges can be positive as well as negative. Correct है guys? Yes or no? Please tell me.
Yes, sir.
Let us suppose Q1 and यहाँ पे Q2 हम लिख रहे हैं और यहाँ पे हम लिख रहे हैं फोर्स. अब बताइएगा, ठीक है ना, फोर्स की जो वैल्यू आएगी वो क्या होगी? If Q1 is positive and Q2 is also positive, फोर्स क्या हो जाएगा? पॉजिटिव या नेगेटिव? Q1 Q2 मल्टीप्लाई करके बताइए. Force will be positive. ठीक है, force will be positive. If Q1 is negative, Q2 is negative, force will be
Positive.
Positive.
if Q, अच्छा, in both of these cases there will be repulsion. Correct?
Yes.
And if one is positive, the other is negative, that means force will be
Negative. Attraction.
Negative.
force will be negative, and this will mean that this is attraction. ठीक है, तो आपको ये समझ में आ रहा है? Positive and negative sign has no role other than telling about repulsion and attraction. And similarly here also the energies with negative sign, please write the negative sign tells about attraction between nucleus and electron. Got this guys? Yes or no? Please tell me.
Yes, sir.
है ना? अच्छा, if something negative charge is telling you about what? Tell me guys. Negative charge is telling you about अरे बोलो भाई. Negative charge is telling you about what?
Attraction.
Attraction.
Attraction. If something is very negative, that means बहुत attraction. Correct है?
Yes, sir.
Right? So उसी तरह समझिए. Please understand. First of all, we will see the qualitative analysis, है ना? ध्यान से. 1, 2, 3, 4. Tell me which will be the most negative energy. First cell में, second में, third में या fourth में? Where will you find the most negative energy?
Fourth.
Sir, first.
सोचिए जरा, अट्रैक्शन जहां ज्यादा वहां ज्यादा
The
नेगेटिव.
first one.
First one, sir.
फर्स्ट वन ना?
Sure.
ऋषिता, you got this?
Yes, sir.
First
ऋषिता,
one, sir.
है ना? ठीक है, उसी तरह से आपको दिख रहा है. Can you see that if this n, the value of n is 1, then this complete value will be larger. That means more negative. That means more negative, है ना? And as the value of n increases, this value will become less and less and less negative. And if I go to infinity, then at this point energy will be equal to how much? Tell me guys. Energy will be equal to how much? If I'm very
Sir,
far,
to be positive.
Positive.
नहीं, नहीं,
Positive.
no, थोड़ा सोचिए. If I'm very far away from, if the electron is very far away from the nucleus, will there be any attraction?
No, sir.
No, sir.
Zero.
If there is no attraction, then energy will be
Zero.
zero. काम होते होते negative 1 lakh, negative, 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 and then it will become zero. See, positive and negative charges के बीच में there will never be any repulsion. But if I make it so far away that the attraction is negligible, I will call the attraction is zero, and that is why the energy of the electron will become zero. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
And understand once again. And if I remove an electron, from an atom and I remove it such a way that remove करने का मतलब क्या हुआ? To take it from 1 to infinity, है ना? If I am removing an electron from the atom, that means I am removing the electron from the influence of nucleus. अगर nucleus का influence समझ में आ रहा है अपनी? Let us suppose I have removed the electrons. The electron is so far away from the nucleus that the electron cannot experience the attraction of nucleus. So what does it mean? Is it inside the atom or outside the atom?
Outside.
Outside the atom, right? Because the influence of nucleus will determine where the atom is. And if I have removed it if the electron is so far away that it is not getting attracted by the nucleus, it is not under the influence of the nucleus, then obviously it is what? It is outside the nucleus, and we have removed an electron from the atom. We have removed the electron from the atom. Now, please write one more thing. After this, the amount of energy required to remove electron from its ground state to infinity is called. अब आपने जब इलेक्ट्रॉन को निकाल लिया किसी एटम से तो कैटायन बन गया, हाँ या ना? करेक्ट, कैटायन ऐसे ही बनता है ना. You have an atom, you remove an electron, it will become cation, and that is why it is known as ionization energy. Ionization energy. That means the electron has to travel from where to where? It has to travel from E1, the first orbit, to infinity. We are talking about hydrogen atom, है ना? जब भी हम किसी specific atom के बारे में बात नहीं कर रहे, Bohr's model Bohr gave the model only for hydrogen atom and hydrogen-like atom. Hydrogen-like atom का मतलब क्या हुआ? Hydrogen-like atom का मतलब हुआ which is having one electron. For example, hydrogen has one electron, helium positive has one electron. Then we have lithium 2 positive, it has only one electron. Okay, that is why I have taken the ground state as 1. ठीक है? To infinity. अच्छा, अब इसमें अगर हम बात करें what is the energy, let us calculate. So this is the initial state and this is the final state, correct? So the delta E, that means the change in energy or the energy required, will be equal to final minus initial. Change ऐसे ही लेते हैं ना, final minus initial, हाँ या ना बताएं?
Yes, sir.
थक गए क्या? बस ये आखिरी है ना, इसके बाद हम खत्म करें, ठीक है? थोड़ा सा ज़्यादा टाइम लग जाएगा, that's it. See here. So this final will be what? E infinity minus E1 है. Sorry, someone was saying something, I could not hear that. No one was saying anything. ठीक है. So E infinity, what is the energy at infinity? Tell me guys. अभी हम लोगों ने कुछ बताया था. When the electron is very far away from the nucleus, it does not have any attraction. That is why the energy of infinity will be
0.
याद आ गया है ना? And E1 क्या हो जाएगा? E1 will be equal to minus 13.6 into Z square. Z square क्या होता है बताएं? For hydrogen, अच्छा Z square पर लिख लेते हैं ना, Z square divided by N square, and whatever this energy will be in terms of electron volts, है ना? So this is the ionization energy. For hydrogen atom, negative and negative will get cancelled, and ionization enthalpy will be equal to minus 13.6 multiplied by Z is equal to 1 for the hydrogen atom. N is also equal to 1 because it is 1, and electron volts, that means ionization enthalpy for hydrogen atom will be minus 13.6 electron volts. Is this clear? Yes or no?
Yes,
Please
sir.
tell me.
Yes, sir.
चलिए, if you want to write something, please write this down.
So done.
Is everyone done?
Done, sir. Yes, sir.
Yes, sir.
Now, just एक छोटा सा बस हम लोग इंफॉर्मेशन लेके क्लास को खत्म करते हैं. You also guys have to give a test ना, तो टेस्ट का तो कम से कम कंप्लीट कराना पड़ेगा, राइट? चलिए, थोड़ी सी बात है. Let us suppose, अच्छा, this is also what we can write now. Energy of nth orbital is equal to, energy of nth orbital is equal to, oh wait a second, ionization enthalpy जो होगा वो पॉजिटिव हो जाएगा ना, my bad. इसको पॉजिटिव कर लीजिए प्लीज, नेगेटिव नेगेटिव पॉजिटिव हो जाएगा, प्लीज इसको पॉजिटिव कर लीजिए. Done everyone?
Yes, sir.
Yes, sir.
So we specified this for electron volt per atom, but हमें ये पता लगा जो electron volt per atom वाला formula है, in that formula we have a constant, and that constant is nothing but it is the ionization enthalpy of hydrogen atom. Correct guys? Please tell me.
Yes, sir.
है ना? Similar way हम लोगों ने radius में भी देखा था. We got a formula for radius and we saw that we got a constant in the formula of radius, and that constant is nothing but the radius of hydrogen atom, but the radius of the first orbit of hydrogen atom. Similarly, this constant is the ionization enthalpy of hydrogen atom. So I can rewrite rather, energy of any orbit will be equal to negative of ionization enthalpy of hydrogen multiplied by what? Tell me guys, what is in the numerator? Z square divided by n square. No matter, अब आपको ionization enthalpy जिस भी यूनिट में दे दी जाए, है ना? They can give you the ionization enthalpy in any unit. You can just plug in this values, है ना? आपने घबराना नहीं है, ठीक है? So write this. This is very important.